This question is about matching parentheses in a given expression. So basically, when we talk about data structures and algorithms, one of the abstract data types is the stack. Right? So basically, it defines some of the functionalities that can be performed on that data type. So for example, we can pop out of the stack. So that is taking the topmost item from the stack. We can push into the stack, right? And we can peek into the stack, which will display basically the top of the item, but will not remove. So it's an abstract data type, and one of the uses of stack is to check whether a given expression, just like this one, is balanced in terms of parentheses, right? So here, when we talk about parentheses, there are three types of parentheses. One is this one, the parenthesis, and the second one is the square brackets, and the third type is the curly brackets, right? So here in this example, we can see all three of them, this parenthesis and square brackets and curly braces, right? So the question is, assume that a stack is used to check for matching parentheses in the above expression. Right? What is the maximum number of tokens that will appear in the stack during the matching parenthesis process of this expression? Okay, so for this we will need a stack, right? So I will represent a stack like this. Check for parentheses in terms of using a stack. We will need to just traverse through this expression. So here, and while traversing, we will need to check whether a given character, a chosen character, is a starting brace, like this one, or this one, or this one, right? So whenever we encounter starting braces, we will just push them into the stack. So here, when we come from left to right, the first open parenthesis we encounter is this one. So we just push that into the stack, right? So this is the stack, and then we move forward and we encounter the second parenthesis, which is an open parenthesis again. So that means we will have to push that also to the stack, right? And we'll move forward. So this one is also taken care of, and we move forward, and here we encounter a closing parenthesis. So which means whenever we encounter a closing parenthesis, what we will do is we will check on the stack whether there's a counterpart of that matching parenthesis, right? So say for example, now here it's the closing parenthesis. Now we will be checking the topmost item of the stack and see whether that's the matching pair. So here in this case it's a matching pair, so it will cancel out and this memory location will be available again, right? So now the top of the stack item is this one, right? And here then we will move forward again, and we will encounter this one, square bracket, right? We will have to push that because it's a starting bracket, and then we move forward and we encounter the brace, right? And it's also a starting one, so we'll have to push into the stack, and we move forward. Now we encounter another closing brace. So whenever we encounter a closing brace, we will have to check whether we have a matching counterpart at the top of the stack. So here it's a curly brace, and what we are trying to match with is with the parenthesis closing. So here this does not match, right? So because of that, this expression is not a balanced parenthesis expression. So we can just go out of the loop and say this is not balanced, right? So at that point the functionality stops, and the question was, what is the maximum number of tokens that will appear in the stack during matching parenthesis process. So here the maximum number of tokens are 3. So 1 2 3. So when we exit out of the loop, the maximum number of tokens were 3. So that is the answer.